Hi folks, I hope you're having a great day in school today. I'm going to go through the homework now, so take it out and correct it as I go through it. This was the question you had last night for homework. The columns in the table below represent the following sets of numbers: natural numbers n, integers z, rational numbers q, irrational numbers r less q, and real numbers r. And I've just put a note for you last night that real numbers are all numbers, including irrational, rational, natural and integers. So every number that you can think of is a real number. Complete the table by writing either yes or no into each box indicating whether each of the numbers root 5, 8, minus 4, 3.5, 3 pi over 4 is or is not an element of each. One box has already been filled in. The yes indicates that the number 8 is an element of the real numbers. Okay, so what I'm going to do to start off, just at the top above each letter, I'm going to write what the number set is. So n is natural numbers, z is the set of integers, positive and negative whole numbers. Natural numbers are positive whole numbers only, integers are positive and negative whole numbers. Q is the set of rational numbers, and we discussed these yesterday. They can be wrote as fractions or terminating decimals or some recurring decimals. R less Q is irrational, and again we spoke about these yesterday. Surds that do not have square roots, and pi amongst others. And then or the set of real numbers, which can be any numbers. All numbers are real numbers. Okay, so let's look at the first one. Root 5 is not a natural number. No. It is not an integer. No. It is not a rational number. It's irrational, yes. And it's also real, as all numbers are real. Let's move on to the next one. 8. 8 is a positive whole number, so it is an element of the natural number set. 8 is also an element of the set of integers. 8 can also be a rational number, so it's yes there also, and it's not an irrational, so we put a no there. Negative 4 is not a natural number. It is an integer. It is also rational. It is not rational, and of course it is real. 3.5 is not a natural number. It is not an integer. It is a rational number. It is not an irrational number, and of course again it is a real number. And the last one, 3 pi over 4. Well, pi is an irrational number. Multiplying it by 3 and dividing it by 4 does not change that. So no, it's not a natural number. It is not an integer. It is not a rational number. It is irrational, and of course again it is real, because all numbers are real. Okay, let's have a look at part 2. In the case of root 5, explain your choice in relation to the set of irrational numbers or less q, i.e. give a reason for whether you wrote either yes or no. Well, we know root 5 is a irrational number, so we wrote yes, it is irrational, and the reason for this is it is an irrational number as it cannot be written in the form a over b, where a and b are elements of integers. Okay, so that's the homework from last night. So now I want you to open up the notes you took down on Wednesday night for homework on the last part, Surds, which we've not gone through. So we've spoken about how surds, irrational numbers such as root 3, root 8, root 13 are said to be expressed in surd form. We will now consider root 100 in two ways. We know the square root of 100 is equal to 10. Also, the square root of 100 is the same as the square root of 25 by 4, which is the same as root 25 by root 4. And we know that the square root of 25 is 5 and the square root of 4 is 2, and that equals 10. That's two different ways of finding the square root of 100, and it illustrates a very important property of surds as stated in the highlighted box over here. Square root of a by b is the same as the square root of a multiplied by the square root of b, and also the square root of a over b is the same as the square root of a over the square root of b. Okay, we will now use these properties to show how a surd can be simplified if one of its factors is a perfect square, such as 4, 9, 16, 25. If we look at the square root of 8, one of its factors, root 4, is a perfect square. Square root of 8 can be written as root 4 by root 2, and we know square root of 4 is 2, so square root of 8 in its simplest form is 2 root 2. Part 2, root 27 is equal to root 9 by root 3. However, root 9 is the same as 3, therefore root 27 in its simplest form is 3 root 3. Root 48 is the same as root 16 by root 3, and again root 16 is 4, so root 48 is equal to 4 root 3. And finally 2 root 45 is the same as 2 by root 9 by root 5. Root 9 is 3, so that's 2 by 3 is 6 root 5 in its simplest form. We are now going to use these properties to help us answer some questions below. So the first thing we're going to look at is adding and subtracting surds. Surds may be added or subtracted only when they have the same irrational parts. If the irrational parts are not the same, we reduce each surd to its simplest form where possible. Okay, so let's do this example now. So we have root 5 plus root 45 minus root 20. Now in order for us to add or subtract these, as we said earlier, the irrational parts must be the same. And we can see here root 5 is not the same as root 45, which is not the same as root 20. So we must find a way to simplify these before we can add and subtract. If I look at root 5, the first term, I cannot, it's a prime number, so therefore its only factors are root 1 by root 5, which doesn't help me in any way. However, if I look at root 45, I can simplify that into its lowest terms, and I can also simplify root 20. So first we express each. Okay, now I want you to pause it here and take down this example, and after that we're then going to move on to the following questions. I want you to do these questions 5, 6, 7, 8, 9 and 10. I'm going to start you off with 5 part I. Root 5 by root 2, we want to write that each of these in the form root n, where n is an integer, while root 5 by root 2 is the same as root 10. Okay. Question 6 asks you to evaluate each of these. Root 5 by root 5, we should be able to do that. Question 7, express each of these surds in their simplest form. Well, root 8 can be wrote as root 4 by root 2, which is equal to 2 root 2. First one is done for you there, and then you should be able to do 8 and